Hello! For my tutorial video, we're going to be talking about RabbitMQ, which is a message queuing technology that the On a Mission team is using for transmitting messages between our mobile units and our central command center. First, I'm going to talk a little bit about what RabbitMQ is and how it works, and then I will give a quick demonstration of how to connect to a RabbitMQ exchange. RabbitMQ is an open-source middleware platform, an implementation of a protocol called Advanced Message Queuing Protocol, or AMQP. AMQP is an application layer protocol like HTTP or FTP, designed specifically for secure message transmission, queuing, or routing. RabbitMQ provides a specific implementation of this protocol, a server written in Erlang which can be installed on any major operating system. Once installed, it can be accessed by client libraries in a wide number of languages. The maintainers of the project have official clients for Java, .NET, and Erlang, but many other third-party libraries exist for other languages as well. The RabbitMQ website uses the metaphor of a post office to describe the way RabbitMQ works. A message is sent from a producer with information about where the message should be delivered. This is equated to dropping a letter in a postal box. You are delivering the message into the system with the general understanding that it will get where it's supposed to go, although the process is asynchronous, so you don't get a direct notification that it's done so. Consumers are the listening clients in the system. They receive messages that are routed to them by the server by maintaining an open connection with a queue, basically a first-in, first-out mailbox from which they can extract messages intended for them. RabbitMQ also contains the concept of an exchange. This is where the postal system metaphor breaks down a little, because an exchange acts as an intermediary between a publisher and multiple queues. There are several different types of exchanges, but the general premise for all of them is the same. The publisher sends their message to the exchange, and the exchange performs the routing logic to deliver the message to all relevant listening queues. The mechanism for this can be a fan-out exchange, one that delivers uniformly to all listening queues, a direct exchange, one that finds the target for the message based on an attached routing key, basically a tag for a target queue, a topic exchange, a more granular direct exchange where messages can be routed based on multiple keys, and a header exchange, similar to a topic except that it uses message headers instead of a routing key. These exchanges offer flexibility and the ability to enact publish-subscribe mechanisms for sending messages to multiple recipients at the same time. For a quick demonstration of RabbitMQ, I will be using these two small projects written using the RabbitMQ C# client library. This first project is set up to receive messages. It sets up a connection object, which will be used to communicate with the RabbitMQ server, creates a new exchange to connect to, if it does not already exist, and then creates a queue on that exchange, which it will listen to indefinitely once the project is started. Therefore, any messages sent to that exchange will automatically be routed into the listening queue and displayed on the program console. We start this program, and we can see it's waiting for logs, listening for any messages that come through that exchange. The second program sends a single message with the current date and time. Again, it sets up a connection to the server, then declares the exchange if it does not already exist. Instead of creating a queue to listen to, however, it builds a message object, in this case information about the current date time, and does a publish to the exchange. This message will then be received by any queues listening to the exchange, such as the one we just started. So if we start this project, it will say that it sent the info. The current date is 3/10/2016 at 2:02 a.m. And if we go back to our listening program, we can see it received that message. The current date is 3/10/2016, 2:02 a.m. So this has been a quick demonstration of RabbitMQ. Obviously, this is only scratching the surface of what you can do with the various tools available in this library, but hopefully this gives a good introduction to why this middleware would be useful for programs involving messaging components.